Cancer feels like a modern disease, something created by cigarettes, pollution, processed food, and the world we live in today. But cancer was here long before any of those things. More than 4,500 years ago, a man living near Lake Baikal in Siberia developed a disease that spread through his bones. He had no hospital, no microscope, no chemotherapy, no idea what was happening inside his body. All we have left of him are his bones, and those bones tell a story that sounds disturbingly familiar. His skeleton was riddled with lesions caused by metastatic cancer. He lived thousands of years before modern medicine, and he was already fighting the same enemy we are still fighting today. Cancer is not a modern invention. It is one of the oldest diseases humanity has ever tried to understand. And for most of our history, we didn't even know what we were looking at. Around 1600 years before Christ, an Egyptian medical text was being written down. Today, we call it the Edwin Smith Papyrus. But the document itself may be much older. Scholars believe the surviving papyrus was copied from an earlier medical work, possibly dating back thousands of years earlier. Most of the document deals with injuries, wounds, fractures, trauma. But one case stands out: a swelling of the breast. The physician examined it. He described what he could see and feel. And then came the conclusion. There was no effective treatment. Imagine being that physician. You can touch the tumor, you can see it growing, you can watch the patient getting weaker, but you have absolutely no idea what is causing it. There is no concept of a cancer cell, no DNA, no immune system theory, no idea that a tiny group of cells could multiply uncontrollably and eventually spread through the body. The physician could describe the disease, but he couldn't explain it. And that was the problem humanity would face for thousands of years. Several centuries later, the mystery reached ancient Greece. Around the 5th or 4th century BCE, physicians associated with Hippocrates began using the Greek words karkinos and carcinoma when describing certain tumors. The word meant crab, and the reason was probably the appearance of some tumors and the veins extending around them. The image was simple: a hard mass in the center, branches spreading outward, like the legs of a crab. Thousands of years later, that ancient word would become something we say every day: cancer. But giving the disease a name didn't mean understanding it. Then came Galen, a physician whose influence would dominate Western medicine for more than a millennium. Galen believed disease was connected to an imbalance of the body's 4 humors, and when it came to cancer, he associated it with an excess of black bile. The theory was wrong, but that is what makes the story fascinating. A wrong idea can survive for centuries when nobody has the tools to prove it wrong. Doctors continued observing tumors. They performed operations. They described different kinds of cancers. They tried medicines, but the basic mystery remained. What actually causes this thing to grow? For centuries, the answer was still hidden inside the body. Then Europe entered the Renaissance, and medicine began to change. Physicians and anatomists increasingly relied on direct observation rather than simply accepting ancient authorities. The human body was opened, drawn, measured, studied. The important breakthrough wasn't that someone suddenly discovered cancer. It was something much more basic. Humans started learning what the body actually looked like. And once you start looking closely enough, you eventually discover something incredible. The body is made of tiny living units. In 1665, Robert Hooke published drawings of what he saw through a microscope. He was looking at a piece of cork, and he saw tiny compartments. They reminded him of the small rooms occupied by monks, so he called them cells. Hooke wasn't looking at cancer. He didn't understand that these tiny structures were the fundamental units of living organisms, but the word would survive. Over the following centuries, microscopes improved. Scientists began studying tissues, and eventually cancer stopped being just a strange lump. It became a disease of cells. In the 19th century, the microscope transformed pathology. Scientists could finally compare diseased tissue with healthy tissue, and one realization changed everything. Cancer wasn't simply some mysterious substance invading the body. It involved our own cells. Rudolf Virchow helped establish cellular pathology and connected disease to changes occurring at the cellular level. That idea was terrifying, because it meant the enemy wasn't necessarily coming from somewhere outside you. It could begin with something that was already part of you. Once doctors began understanding tumors as physical growths, another question became urgent. Could you simply cut them out? Sometimes yes, and sometimes no. In the 19th century, surgery became increasingly aggressive. In 1882, William Halsted performed what became known as the radical mastectomy for breast cancer. The operation removed not just the breast, but surrounding tissues and lymph nodes. The thinking was simple. If cancer could spread through nearby tissue, perhaps removing more tissue would stop it. Sometimes surgery saved lives, but it could also leave patients severely disfigured, and doctors were still fighting an enemy they didn't fully understand. Then, in 1895, Wilhelm Röntgen discovered X-rays. Suddenly, doctors could look inside the human body without cutting it open. And very quickly, scientists began asking another question. If radiation could affect tissue, could it also destroy a tumor? The answer was yes. But there was a catch. Radiation could damage healthy cells too. The crude treatments of the early 20th century would eventually evolve into carefully planned radiation therapy. Today, radiation can be precisely aimed at tumors and used to destroy cancer cells or slow their growth. For the first time, humanity had a weapon that could attack cancer without a surgeon's knife. And then came one of the strangest chapters in the entire history of cancer. A chemical weapon helped inspire a new kind of treatment. Nitrogen mustard was related to the chemical warfare agent mustard gas. Scientists already knew that exposure to these compounds could severely damage blood-forming tissues. During World War II, researchers at Yale began investigating whether nitrogen mustard might be useful against cancers of the blood and lymphatic system. And then, in December 1943, the German bombing of the Italian port of Bari destroyed ships carrying mustard agent. The disaster exposed people to the chemical. Doctors observed profound damage to white blood cells. The connection was impossible to ignore. If a chemical could destroy rapidly dividing blood cells, could something like it be used against cancer? Researchers tried it, and some patients experienced tumor regression. Chemotherapy had begun to emerge. A weapon designed to destroy human bodies had helped reveal a way to fight one of humanity's oldest diseases. But the biggest change was still ahead. Scientists discovered that cancer wasn't one disease, it was many diseases. different cancers behaved differently. They responded to different treatments, and some could be cured while others remained extraordinarily difficult to treat. Chemotherapy expanded, hormone treatments emerged, better surgery and radiation followed. Scientists began identifying environmental causes of cancer, genetic changes, viruses, and other biological mechanisms. And the results could be extraordinary. Childhood acute lymphoblastic leukemia, once almost uniformly fatal, became highly treatable. For children diagnosed in the United States today, 5-year survival for all is above 90%. Today, we are entering another chapter. Scientists can sequence tumors. They can identify mutations. They can target specific proteins. And they can sometimes use the patient's own immune system to attack cancer. Cancer treatment is no longer simply about cutting something out or poisoning everything that grows quickly. The goal is increasingly to understand exactly what makes a particular cancer different and attack that weakness. But here's the truth. We haven't won. Cancer still kills millions. Some cancers can be cured, some can be controlled for years, and some remain incredibly difficult to treat. The history of cancer isn't the story of humanity defeating one enemy. It's the story of humanity slowly learning what the enemy actually is. 5,000 years ago, an Egyptian physician could only describe a tumor. He could touch it. He could see it. And eventually, he had to admit there was nothing he could do. Today, we can see cancer at the cellular level. We can examine its DNA. We can scan it. We can operate on it. We can attack it with radiation. We can treat it with drugs. And sometimes we can cure it. That's the strange thing about history. The biggest victories don't always happen in one dramatic moment. Sometimes they happen slowly. One observation, one microscope, one failed experiment, one patient who survives, one discovery building on another. For 5,000 years, cancer was something humans could see, but could not understand. Now we understand more than ever. And perhaps the most important chapter of its history is the one we're living right now. This is Past Unlocked History,